Hi, I am Sandra Hawkins and I want to explain inheritance in Java. So I've typed up a parent class here already and it contains a name member variable. I have a static variable in just to explain how that works with inheritance. I have two constructors and I have a get name, a set name and a toString. So just to explain exactly what happens with inheritance. So a parent class can exist to provide members, which are variables and methods, to a child class, basically to save that child class or subclass as it's known as, to save it, typing in everything again. So inheritance exists to reuse classes, to reuse functionality. So my parent class, for it to be inherited by another class, the class, I've called mine child just to make it obvious that it is a child, but it's known as a subclass in Java. For it to be the subclass, it must have the keyword extends and which class that it is a child of. So extends parent. And for a member, now a member is a member variable or a method. Member variable or method, so they're known as members. For a member to be inherited, it can't be private. So I have a member variable here that's private. That's not visible in a child class. But if you create an object of it, if you use the child class to instantiate it, to create an object of it, the object will get in memory a copy of any of those member variables. Even though they're private, a child is made up of those member variables. Private means that it can't be accessed in code in the child class. So something that's private is only visible in the class that it's in. Otherwise, it will be public, protected, or no modifier, which is known as default. And depending on which modifier, accessibility modifier they're called, depending on which one you use, it has a different effect in the child class, whether it's in the same package or whether it is a child, like a subclass or not. I will cover those in a separate video. So for a member to be inherited, it can't be private and it must be one of public, protected or default, and then it can be inherited. I have a static variable here. So a static variable, now this is a tricky one. It's not inherited, but it is visible in the child class. So static variable, that belongs to the class that it's in. If you can imagine, there's a set of memory set aside for each class. So the parent has its own little set of memory, and in it, and that static goes in there. If I go and create parent objects, so I go parent p1 equals new parent, that will get a copy of any of the member variables. So if any parent objects I create, it will get a name. It will not get a copy of that static variable. That belongs, if it's a class variable or a static variable, it belongs to the class, not to any of the objects. So any parent objects I create, each one will get a name. Now I'm going to start looking at the constructors here. Constructors are not inherited by a child class or a subclass, but they can be seen and they can be called. So what does it mean in terms of inheritance? What does a child class get? Something that is public, is not a constructor, public, protected or default, is not a constructor. So a regular method will be inherited by a child class. It's as if it's copied into it. So I'm going to demonstrate here about the constructors and the methods. Okay, so I have a child class. Constructors, firstly, are not inherited. They can be called. So a child class should really provide its own constructors. So public child, I'm going to have one here that takes no parameters, and I'm going to put in another one. No, I'm not, because I don't have any other member variables yet. So I have a child class created here. Can it call a parent constructor? Yes, but it must use the keywords super and round brackets. So when you see super with round brackets, what I do is I think, well, what's the parent class? In this case, it is actually parent. That's known as the super class or parent class. The super class is parent, so that's like a call to parent and no parameters. So it would call the parent constructor there with no parameters. Now, if you don't put that line of code in, that's implicit. So if you don't put a call to the parent's constructor in, you will get a call to the parent's no argument constructor. because you can't exist before your parent existed first, and it's the same in programming. So the parent object or class has to be created first before the child object can exist. Now, what I'm going to do over here back in the parent, I'm going to put some code in here. I have an object counter to count how many instances of the objects are created. So I'm going to put object counter plus plus. So just to increment it by 1. I have a second constructor here that's going to deal with the name, and to make sure that however I create a parent object, there are 2 ways to create a parent object, whichever one I decide to call in my code. To make sure that object counter gets incremented, I copy that code and pop it in here, but the better thing to do is call the constructor in the same class with no parameters. So when you see this, go, what's the name of the class? Parent. It says parent in round brackets. So that will call the constructor here with no parameters. Now I have a main method. I'm going to open that and just test this out. Just drag it over here so we can see everything. So in main, I'm going to create a parent. Let's call this one dad equals new parent, new parent. Now, okay, I can print out there at the minute. I can print out, say I want to print out that object counter, I can do dad.object counter. Now, that's a static variable. Static variables can be called on an instance, but they should be called on the name of the class instead. That's the correct way to do it. And if I run that, wait for the printout. So 1 is just printed out there. So that's so far so good. Now, just to explain the rest of this, I have a get name, I have a set name, I have a constructor that takes in a name. So let's give the dad a name. I'll go back here. So my reference variable is called dad.setName, and we'll call it dad, but just there a capital D. And if I do a print out there before that, print out, and if I just print out the reference variable, my reference variable is called dad, that will implicitly call the toString method in the class, and the toString is going to return the name. So still just checking that everything here is okay. So name is dad and number of objects created is 1. Number of objects is created as 1 because I only have called new. I've only done that once. Now I have a child class. I've only 1 constructor in it, so that allows me to create a child object. Child, we call this one C1 equals new child. Equals new child. And if I do a print out for C1, that will implicitly call the toString, which I don't have one, but the toString will be inherited. So let me just explain what's happening here in the code that I have so far. So from the beginning here, new parent, that gives me a parent object. So dad will refer to a parent object in memory, and a parent object when it's set up will get a name member variable. Excuse my bad writing here with the mouse. That will get a name member variable. Set name, dad will be passed into the set name method. Name will get assigned, dad will get assigned to this name member variable, so that my parent object here has been created will get a name set to dad. When I do a print out of dad, that will call the toString. It prints out the name, so we'll get name as dad. Object counter will go up by 1. Go to 1. When I now do C1 refers to a new child object, that will call the child constructor here. That will implicitly call the parents constructor. The first line in there is actually a call to the object's parent constructor, the object's constructor as well. So object will be the superclass here. It will go off, set up any variables or anything in the object class. It'll come back. It'll then set up the name member variable. So when this is happening, a child object has been set up. It's getting a name member variable here, and it will get a default value of null. Then back to the constructor. So once that's set up in memory, back to the parent constructor, add 1 to the object counter, back to where that was called from. So that's the child. now set up in memory with a name with null. Back from here, back up to my main, then it'll do a printout of the toString. It'll look in the child class for the toString. There isn't one, but it does inherit the toString from the parent class. So it will print out name is, and in this case it will print out null because that hasn't been set. Now I need to switch off all the lines so I can run that. So we have name dad and the second name there is null. Now just to tidy this up a little bit more, I'll just do a printout here of, I'll just do a printout of the static variable which is in the parent class, so that's our object counter. And now just to do a little bit more work down here in the child class. I'm going to run that again there just so you can see these two objects now created. Now, so the first thing I'm going to do is I'm going to put in the toString class, toString, and then explain what's happening here. So the toString class, I'm now putting in the child's own copy of the toString, toString method. So it's putting in its own copy of that method. When you put in a method the exact same as what's in the parent class or the superclass, it's known as overriding. So essentially, I'm replacing this method that has been inherited. So to be inherited means that it's kind of copied and pasted in. I'm now typing in my own, I'm replacing it, so replacing it is known as overriding. When you override the visibility modifier, which is public, I can't make that less accessible. So less will be protected or default or private. I can't make it any less accessible. So if it's public in the parent, it must be public in the child. Must have the same return type, must have the same name, must have the exact same parameter list. So I have overridden this, I've overridden the toString. It's overridden. It doesn't compile right now because it says it returns a string and I haven't returned a string. Now, so I would return, I want to add something else in here to make this class a little bit better. So at the minute, I'm going to leave that blank just while I add in a little bit more into the child class. I'll get rid of that main there for a second. So what I'm going to add in here for my child class to make it a little bit different from the parent, I'm going to have a string school address, and underneath my constructor here I'm going to add in, I'm going to call source, generate getters and setters for that school address. I'm also going to pop in a constructor, so right click source, generate constructor using fields. Now, just to check of what the code that I have here already, make sure that I'm happy with it. I have a member variable, school address. I have a constructor that takes nothing and doesn't do anything. That's fine. It will implicitly call the parents noargs constructor. I have a constructor that takes in any member variables that I have here. I only have one, so that's fine. I'm taking out that's called a super parents constructor because it will do that implicitly, so there's no need to pop that in. So anything I pass in will get assigned to the current object's member variable school address, get a return it, and the set is underneath. And okay, now my toString. So what the toString should do is return a string representing the member variables of this class. This class is made up of two member variables, the school address and the name. School address and the name. So what I want to do in here is a couple of options here. I can say the name is, and concatenate on name, have a deliberate mistake there, so if you can figure that out, and the school address, and here, concatenate on the school address. Now, just to explain this. Name is not visible. It's not visible because it's not in this class. The child would inherit anything from its superclass, so anything that's not private, but the name is private. So name here is not inherited. So how can I get the name from the parent when the child class, it does get a copy of it when I create a child object in my main. Just open that again there. When I create a child object, new child, that will now get a copy of the name and the school address. But I don't have access to name. So it's private in the parent. The only way that it's visible in the child class is by calling getName. But you could, if you wanted to, instead of doing that, so instead of that one there, just move that out of the way, you could call the parent toString method. So super.toString. Add on to that. So super.toString. That will call the parent's toString method. That will give me the name of the parent or the child, depending on which object it's called on. And now it will come back here and give me the school address. Now it'll shove this onto the name, the end of it, so I'll put in a new line there. Let's test out what I have so far. I'm just going to run my main method. So I've created two children. I have a dad, I have a child with no name, and a school address that's also null. So I'll just fix up my class to give those two values. Yeah, we're nearly there. So I have a constructor here that takes in the school address. Okay, all of the member variables. I'd like it to take in the name there as well. String name. Now, how do I set the name? So I can't do this dot name equals name because, for the reason I've just explained, that name is private and can't be seen in the child class. You have two options here. You can call set name because that's inherited. So inherited means it's like it's copied and pasted in here. Or instead of that, I can call the parent, or the superclasses constructor. So it's called parent. Oh, sorry, you cannot call a parent constructor by its name. Super and round brackets. If I want to call a constructor that takes in a string, I need to pass in a string, and the string that's been passed in there is that variable, that local variable school address. Now, let me check. I have a constructor that doesn't take anything. It will call the parent's no-args constructor, which will increment the counter. I have a second constructor that takes in a name I pass in and a school address. Then the school address, that's the wrong one. That should be the name, if you'd spotted that. The name will get passed to the parent's constructor that takes a string and assign it to the current object's member variable name. School address is set directly, and my toString will, if that's called, will call the parent's toString, which will give me back the name, come back here and add on the school address. Now, let me go back to my main. I have a child class. Let's create another child class here just so you can see the difference. So child C2 equals new child. Now I have a constructor that takes in a name for that child and their school address. So let's go with Bob, and Bob goes to school in Dublin. And semicolon at the end there. Oops. Now, I want to do a printout here. So if I do a printout of C2, that implicitly calls a toString in the child class, which I have typed in. I've replaced the one from the parent. I've overridden the parent's toString. And let's just see here as well how many child objects create at this, how many objects are created. Number of objects created. Now I'm going to take out these other printouts here of the parent.object counter and take out that one just to tidy it up. Can I say child.object counter? Yes, I can. So the object counter, it's not inherited in the sense that it's not copied into the child class, because again, something that's static belongs to the parent class. The child objects don't get a copy of it. So that's why I've said it's not inherited. They're not getting a copy of it. But they do get, they can see it, they can use it. So to call the object counter from, I'm in main here, I'm not in the parent or the child class, I can use the parent class name, the child class name, or I can use one of the objects. That's not how static variables should be called. They should be called on the class name that they're in, but just be aware that you can use the child class as well, its name, because it has access to them. Now, let me run that and see, is that okay? So we have dad, name is null. That's my second object there, the second child object. I didn't pass in or set anything for that, so that's why the name is null, school address is null. I did pass Bob and Dublin into the constructor for the third object I created, and the number of objects created there is 3. Now, I'll very briefly just just explain what's going on here. Child. So when the parent class there, when the parent is called, that goes to the parent constructor. The number of object counter goes up by 1. Dad.setName, that would set up the name for the parent object, and I printed out the toString, gives back the name. The child class. So the child class, that calls the child constructor. I'm going to flick over here. That calls the child constructor. It will make a call to the parents noargs constructor. It will, behind the scenes, give the child a copy of that member variable name. It will add 1 to the counter. Back to the calling code here in main. toString will print out, go to the child class, call the toString method. toString method, it will call the superclass's toString method. That will give out the name. It hasn't been set, so that's null. Back to here, prints out the school address that hadn't been set, that will be null. Back to main, creates another new child object, this time calls a constructor, sends in Bob and Dublin into the child class with 2 parameters, or child constructor with 2 parameters. That sends Bob to the parents constructor that takes a string. That will call the constructor with no arguments, so it'll add 1 to the counter, make it go to 3. Back down, set Bob to this object's name. So we're on the 3rd object here, the child. It'll go back here. The school address, Dublin, gets assigned to the current object's school address, so it sends the school address to Dublin. Back to where that was called from, here. Printout called the toString again in the child. toString in the child. Calls the parents toString. Go down here. That will print out the name, Bob. It'll come back to here and add on the school address. Back to main, and then there's a printout for parent.objectCounter, and that's where it will print out 3. So that was a little lesson on inheritance. In later videos, I will add on one to look at the protected and default and private in a little bit more detail. And that is it. Thank you.